Welcome to Mr. Powers Teaches Algebra. We've been talking about series, and there is a formula for finding a partial sum. We've talked about partial sums also. There is a formula for the partial sum of an arithmetic series. So I want to do a couple examples first. And so I got a little outline here. I'm going to do a couple examples. I got my A sub n, my B sub n, where I find some really short partial sums. So like I'm just going to get the first 6 terms of each one, and I'm going to see if I can notice anything, see if I can find some patterns, some tricks to finding these, so that I could do something crazy like find the first 200, the sum of the first 200 terms of a sequence without using a calculator, without adding 200 separate numbers. Okay, and if we can do that, then I want to go ahead and extend the same thinking to finding a formula in general for any arithmetic sequence. So we'll start with a general arithmetic sequence rather than a specific one like these up here, and see if we can use the same strategies in order to develop the formula. And so if you really want to understand the formula that is out there everywhere, hopefully this will help. Okay, so first things first, we got this A sub n. And I'm going to try to copy it here. And we want to find the first 6 terms. So let's do that. Okay, and that's really easy. So first off, the first 6 terms are going to be, and we can see here, it's just the counting numbers. It is arithmetic because we go +1, then +1, then +1, and so on and so forth. So I'm going to be adding the first 6. So S sub 6 is going to be 1 plus 2 plus 3 plus 4 plus 5 plus 6. Now, I noticed something because I am so incredibly brilliant and clever that if I switch the order of S6, and instead of counting up, I count down, that something really interesting happens. So I'm going to rewrite it again, S sub 6 right here. But I'm going to write it this way: 6 plus 5 plus 4 plus 3 plus 2 plus 1. And what I'm going to get then, and this is an algebra step here, I'm going to go ahead and add straight down. And I'm going to have 2 of these S sub 6s. And what do I get? 6 plus 1 is 7, plus 2 plus 5 is 7. 3 plus 4 is 7. 4 plus 3 is 7. Wow, I'm sure getting a lot of 7s. And what is 7? 7 was my first term plus my 6th term, plus the last term I was adding. Now that's really interesting. And how many of those do I have? Well, I have 6 of those, right? That was n, wasn't it? So what do I get? I get this 6 times 7, and then that's 2 times S6. So I don't want 2 times S6. I added S6 twice. I wanted 1, right? So I have double here what I should be. 6 times 7 is double what I should have. I need to divide that by 2 to get the actual answer. And that's going to be 6 times 7 is 42. So 3 times 7 is 21. Should add up to 21. So now that was really neat. Now, does that work with everything? If I switch the order of any arithmetic sequence and then start adding the terms up like that, will it always add up to what the same as the first and the last term? That'd be really cool if that's the way it works. So let's try it again. And you can verify 6 plus 5 plus 4 plus 3 plus 2 plus 1 is 21 pretty easily. I'll let you go ahead and do that. Let's go ahead and try the next one. So we'll go ahead and try to copy that one. Shoot. Yeah, we can do it. And let's play with that. Okay. Let's go ahead. We want S6 for this. That's going to be 3 plus 5 plus 7 plus 9, 2, 3, 4. 3, 7, 9, 1, 2, 3, 4, 5. So the next one's 11. And then the sixth term will be 13. Because what am I doing? I'm adding 2 every time, right? Add 2, add 2, add 2. So it is arithmetic. Verify that. So add 2, add 2, add 2, add 2, add 2. Okay, 1, 2, 3, 4, 5, 6. What is adding that up? Let's try to use my same trick. I could add these up by hand very easily, so we can easily verify the answer. Let's try that same trick again, where I rewrite these guys, but backwards. So the 13 first, then the 11, then the 9, then 7, then the 5, then the 3. Now, what is 3 plus 13? My first plus my last term is 16. Am I going to get a bunch of 16s again? I think so. 2 times S6. Yep, 13 plus 3 is 16. 11 plus 5 is 16. Oh, yeah, it totally worked again. That is really cool. It's really fascinating. Love it. You love to see it. You love to see it. Okay, so that's, again, we got the same trick. Okay, and so it is, once again, that's 6 times 16. And once again, 16 was the same as my A1 plus my A6. Or we could say it was A1 plus A sub n, because we were going, our n was 6. Okay, and that's same thing we had up here. A1 plus A6, but really it was A1 plus AN. We're going first term plus the last term we care about. The 6 was our n. Okay. So we got the same thing again, and we got 2 of those. So we got 2 times S6 equals that. But of course, we did double because I added it twice. So we got to divide that by 2. And my S6 could be, let's see, 3 times 16, 30, plus 18 is 48. And let's see here. Yep. Okay. So if I didn't do anything weird, that should work. Okay. So what is the pattern? Now, if we're going to guess what our pattern is, if we're trying to say, hey, you know, I think I got a formula here. It's looking like there is a pattern. What would that pattern be? What would S sub n be? So in other words, if A sub n is a sequence, an arithmetic sequence, if A sub n is an arithmetic sequence, what is our partial sum S sub n? Okay. Well, I think we got it. S sub n is going to be, each time we got n times A sub 1 plus A sub n. Right? This 6 was n. The 16 was A sub 1 plus A sub n. Here again, n times 7. 7 was A sub 1 plus A sub n. Okay, so it looks like it's n times A sub 1 plus A sub n. And then we had to divide by 2 every time. Divide by 2. That's our formula. And just to be clear, n is the number of terms we're adding. A sub 1 is the first term being added, and a sub n is the last term we're adding. So with just those 3 pieces of information, as long as it's arithmetic, we know exactly how to find the partial sum. And so, of course, when doing it with this 6 terms is kind of silly. Like, I can add 6 numbers pretty easy enough. But now, if we're going with something like 600 or 200 or whatever, a bunch of terms, this formula has very much value to us. Makes it a lot easier. It even lowers the computing power needed if you use a computer to do it. In fact, I'll bet you a lot of calculators, if they notice it's arithmetic, just straight up go here, maybe. They'll like, oh, this is easier. This will be quicker. Let's do this. I don't know. Okay. So you know what? I think that'll do it for this video. Okay? And in the next one, we're going to use the same method for a general arithmetic sequence to develop the same formula here, because that's going to be a better proof. But this is pretty good explanation, I think. This pretty much, we kind of see this pattern, but if we want to be really sure, we want to prove it a little differently. So I'll do that in the next video. So until next time, enjoy doing math.